Okay, so hello everyone. I'm Guy Levy, the Director of Innovation at the Center for Educational Technology in Tel Aviv, Israel. And we're now going to go into our learning object repository in science and math. Some words about our center in Tel Aviv. We are a market leader in technology-based educational solutions for over 40 years now. We provide state-of-the-art curriculum-based interactive content in 4 main areas. We are the largest printed and digital textbook in Israel. We develop interactive learning objects, which we'll soon see. We into online and blended learning. We just launched a virtual high school 2 months ago. And we're doing large-scale online assessment. These 4 competencies, later you'll see how they are integrated into our advanced and sophisticated learning objects. 21st Century Skill 2015 PISA test. The Center for Educational Technology is a partner of the Educational Testing Service of Princeton, which developed computer-based tests for the OECD Program for International Student Assessment, known as PISA. And for PISA 2015, we are going to develop the interactive content in science literacy and what they call collaborative problem solving, CPS. Now, we know that STEM education, which is already the next big thing with huge investments in education systems, we have several issues that at stake which we need to understand. As 21st century global market change, and students must excel in STEM to be relevant to this market, to the workplace. High-tech companies have jobs that they cannot fill today because of the lack of qualified candidates. Number of students going into this field is not growing comparable to the rate of market demands. Actually, it's decreasing, and we can see also in the United States the budget that is invested in STEM education. And actually, teacher, over 50% of 8th grade teacher, we know it from Israel, we know it from the States, from the United Kingdom, teacher who does not hold degree in the field of math and sciences, and this is something that we need to relate to. And teacher are in a position where they need to focus on lesson, and they have difficulties in fusing real-world examples that would help students frame of reference. Now, students today we must integrate the real world into the curriculum, into what we're doing. So what we're going to see now is how we integrated in the Center for Educational Technology this sophisticated scientific learning object into our digital textbook platform. So here is Mind Me the Hebrew. This is a textbook for 7th grade in life sciences. And the textbook is printed and digital. We're now seeing the digital textbook. This is the first page, and we'll go directly into page 109, and what we see is the text, and when we scroll down, we can look at on page 110, we see this girl, she's exercising. While she's exercising, 4 body parts are participating in this exercise, and the teacher has to teach the pupils what are the relationship between these 4 body parts and the way they interact and the way they work in her system. Pretty tough task. On the digital textbook, click in and we've got the simulation. She's starting to run. We'll see that in English shortly. And we can see the change of the heart rate, the respiration, the oxygen consumption, and the body temperature all together, and we can stop and ask questions and discuss it with the students. We can continue, make her faster, or decrease her speed of running, and see how it does affect the body system. So these learning object is integrated and embedded in the digital textbook. Now, hundreds of learning objects that are being embedded and integrated in these digital textbook facilitate, enable the teacher to teach differently, to go into the different levels of the students in the classroom, and also provide it for them as part of their homework or drill and practice if they have a one-to-one classroom, or taking it to as homework because it's a web-based, it's in the cloud, and it is just connect to the internet and log in. What we're going to see now, we'll see how the learning objects that we have developed, the sophisticated learning object, help us teach, help us go into and integrate the curriculum with 21st century skills, talking about critical thinking, talking about higher order thinking, and creativity and innovation. And the idea here is that the learning object must be advanced in terms of pedagogy and the way you integrate it into your lesson, into the classroom, into the learning activity. So what we have here is an example of energy in physics for 7th, 8th grade junior high school. And this learning object enabled the teacher to teach potential and kinetic energy. And we can see now how it works while this young skateboard rider is moving. But in order to help all the pupils in the classroom understand, we have three types of representation: a pie chart, energy plot, or a bar chart. Now we stop it and we add the friction. When we add the friction, we see here that heat energy is coming into the game. We move the young guy, and we see the law of energy conservation now in play. And again, we can see it in a pie chart. We can look at it as an energy plot. Now, our science team said it's sometimes hard for the student to see the relationship, the connection between the position of the skateboard rider and the graph. So they added slow motion. The slow motion as a pedagogic tool enables us to see the relationship, the connection between the position of the skateboard rider and the graph itself. Of course, you can pause and you can discuss it with the student and see exactly how it works. Now, this simulation, this virtual lab is associated with drill and practice and inquiry-based, internet-based work. So we can see explanation. We have drag and drop and check if you're right and you're done, and you see what you're right and what you're wrong, and you can practice again. We have a multiple choice section, and we usually combine user-generated content to take the real world into the learning process. And we go into the web and we look at a real skateboard rider, and we ask questions of higher order thinking that the students have to look at the real world and interact it and compare it with the theory and provide explanation, inquiry-based explanation. And this is something that enable us, or that's one of the reasons we're chosen by ETS to develop the PISA 2015 in terms of scientific literacy. What I want to show you now is the three others learning objects from the fields of biology, optics, and others, and to see the sophistication and the advanced pedagogy inside them. This one you already saw in Hebrew. We have it now in English. This young lady is running, and we see the 4 different body parts that are working. Of course, we can speed her down and see immediately the change in each of the body parts. The body temperature is going down, the oxygen consumption is going down, etc. Now, this learning object is also associated with inquiry-based learning, and it's rather easy. The virtual lab, the simulation, which is controlled by the students and the teacher, of course, enable to run this inquiry-based learning. And first thing you ask, let's look at the heart rate and the respiration rate in 0, in rest, in walk, in jogging, and in running, and see the differences. Now, the students, it's rather easy to look at rest, and then to start move to 3 kilometers, etc., etc. So it's so this is one of the options. Again, we have different type of interaction. It could be true or false. It can be sentence completion from a drop-down menu that helps the teacher teach or the students to work at home. And of course, we do have also a drag and drop to fill up the complete chart of the body as a system while you exercise and run. So again, all these learning objects can be integrated in different systems, in different platform. It could be in the ebook or in the learning management system that your company or your clients are working with. Third is simulation in optics. Optics, it's a field in physics which you have to do lots of laboratories. And running laboratories in optics, you need to go to the lab, you need to know how to operate the system. However, we're not saying that you should avoid real laboratories, but the virtual laboratory enables you to support the real laboratories, and let's see how it works. Well, we can set shadows and light, and we can select different types of, actually we can take this away, and we can have this one. Now we can select multiple sources of light. So we take another source of light, and we position it anywhere we want in this term. We have measurement tools. We can measure the angles and compare the angles of one source of light to the other. Of course, depends on the distance from the object. We can measure the distance between the object and the shadows, and between the other object, the object and the other shadow, and do the measurement. And again, The idea here is not only to provide a simulation that shows the students what does it mean, lights and shadows in optics. The idea here to provide them an inquiry-based learning object simulation that they can measure and they can do the inquiry themselves with the directions of the teacher, or even as in collaboration, as we talk about 21st century skills. Also here there are questions and tasks that students have to fill, but of course it is also dependent upon the way the teacher is handling that, and we've just seen that the lack of teachers in science and math that we have almost anywhere. Last but not least, it's a very interesting and I think also sophisticated learning object which deals with the food chain in a pond. And this is an issue that teachers are really having hard time teaching students and making them understand the equilibrium, the relationship between the different types of species in the pond. And what we have here, we can look at the, when we play it, we can see the equilibrium in this regard. We can see it in a bar chart, in a plot, or we can see it in a bar chart. It depends. Each of them enable the teacher to explain different ideas and concepts. But we can see actually the equilibrium. Now we can stop that and change any of them. For example, if we'll take down the producer from 20,000 to 10,000, let's see how it would affect the food chain in the pond. So we run it and we see the change. Now we can stop and discuss what we see and ask the student, what do you think the next move is going to be in terms of time? And we can see now the algorithm that was developed here is rather sophisticated and enable us to multiple changes in the creatures in the pond in terms of the way they are interacting. So basically, again here we do have exercise, inquiry-based experiments that we ask the students to conduct, experiment that the teacher can conduct with the student. Again, if you have a one-to-one classroom, they can work in collaboration in groups and change and conduct different experiments, and they go to the whiteboard or the projector and talk about it and discuss it. So there's different ways of using these advanced and sophisticated learning objects. Basically, these are sample of the hundreds of learning objects that we have in science and math, K-12, from first grade to 12th grade, that we can offer independently of your system or your ebooks. And I guess that's it in terms of the samples. And we're now, with my colleagues here, open to questions if you have.